This is activity 3. Which would you rather solve from lesson 6, strategic solving? And the idea behind this activity is to look at each of these equations with some eye towards, well, gee, this is a hard equation to solve, or this is an easy equation to solve, and this is how I would do it before you jump in and begin to solve the equation. So you're supposed to select 3 equations that you think are the least difficult from these 10 equations, and select 3 equations which you think are the most difficult from these 10 equations. And then choose 3 of these equations to solve. One that you think is more difficult, one that you think is easier, and then a third one of your choice, whatever you want to do. I ended up solving all 10 of them. So this turns out to be a rather long video. But I thought that was necessary, and it's a good idea to do, and then go back and look in hindsight after you've solved each one, gee, which ones did turn out to be easier, which ones did turn out to be harder, and why, of course. And so I'm going to go over the 3 that I thought were the most difficult, just looking at them in the beginning. So A, G, and H. And I'm going to list some reasons why I thought they were difficult. So A has fractions with different denominators. So here's a 6 as the denominator, and here's a 3 as the denominator. So at some point in time, you have to deal with that. Negative fraction that's distributed. So a negative 5/6 gets distributed to this 8. It gets multiplied by this 8, and also gets multiplied, this 5b gets multiplied by negative 5/6. G, you have m, the variable that's in the numerator, and on top of that, you add in one case. So you're adding the variable. In another case, you're subtracting from the variable, actually. And so you're adding and subtracting in the numerator. So how do you deal with that? How do you get this into some form that you can solve? And H, this tends to be, it doesn't look that hard, but it tends to be confusing for students. When you have you're subtracting a 5 in this case, and then you're going to distribute that 5. You're going to multiply p by 5 and 4 by 5. And that's not hard on the surface. What's hard is, or what's confusing is, what's the sign after you do that multiplication? And how do you solve the equation after that? And how do you distribute this subtraction? Can you even distribute subtraction? So p minus, and then 8 minus p. And I would say that no, you cannot distribute an operation. You can only distribute factors, numbers. You can't distribute subtraction, or you can't distribute addition. And so I'll go over how you rewrite this equation in a form that makes much more sense of what you're doing as far as distributing the 5, or distributing what turns out to be a negative 1 in this case. But we'll get there. Okay, this is problem A. And the issues were fractions with different denominators. So how do you deal with these fractions with a denominator of 6 and a denominator of 3, or 5/6 and 5/3? And how do you distribute a negative fraction? So this is a negative 5/6. It's going to be 5/6 times 8, and negative 5/6 times 5b. To get rid of the denominators, you can multiply through by that denominator. So 6 times 1/6, if you look at this as 1/6 instead of 5/6, well, 6 times 1/6 is 1. These 6's will cancel out. And you have to, the issue here is to remember to multiply each term by that 6. So it's 6 times this whole side. This is all written as one term right now. But you have to multiply both of these 2 terms by 6 as well. So 6 times 75 and 6 times 5/3 b. Some students will look at this and only multiply the 6 times 5/3 b and forget about the 75. So you go through that multiplication. So I just wrote it out. I put parentheses around what I'm multiplying just to keep that straight. And so now 6 times a negative 5/6. And what I'd like to do is pull out that negative 1. This is a negative 1 times a positive 5/6, and work with it from there. So it's 6 times a negative 1 times 5 6. These 6's cancel out. 6 divided by 6 is 1. And now you're left with a negative 1 times 5. And I oftentimes say that that negative 1 is the opposite. What's the opposite of 5? Well, it is a negative 5. So what's the opposite of this 5 right here? It is negative 5. And so it's a negative 5 times 8 plus 5b. And that equals, over here, what's happened is that 6 times 5/3 is, you can factor out the 6, 2 times 3 times 5, so that you can see these 3's cancel out. 3 divided by 3 is 1. So this is the 6 right here. 2 times 3 is 6, times 5 divided by 3. And that 3 divided by 3 is 1. So you're left with 10b, 2 times 5 times b. And now you can distribute the negative 5, and it makes more sense. A little bit easier to deal with. It's no longer a fraction. So 8 times negative 5 is negative 40. And again, I would look at this as the opposite of 5 times 5b. So what's 5 times 5b? That's 25b. And what's the opposite of that? A negative 25b. And that equals, nothing's changed over here. All you're doing is distributing this negative 5 in this case. So this is not one of those places where you have, whatever you do to one side, you have to do the other side. It's just renaming this negative 5 times 8 plus 5b in a different way. You're distributing that negative 5 to get negative 40 plus a negative 25b. Now I want to get rid of this 450. And so to do that, I'm going to add the additive inverse of 450, because if I add the additive inverse, then it equals 0. So 450 plus the additive inverse of 450 is a negative 450. This will become 0. And that means that, in essence, you can see it as moving this 450 to the other side of the equal sign, and now it becomes negative because you're adding a negative 450 to both sides. And so this negative 40 plus negative 450, this is going to become a negative 490 plus, and you see where this negative 25b is going to then go over to this side and become a positive 25b. Because what you're going to do to get rid of that negative 25b is add the additive inverse to both sides. Well, the additive inverse of a negative 25b is a positive 25b. Add that positive 25b, and so this becomes 10b plus 25b is 35b. And to get rid of the coefficient, the number that's next to the variable that goes along with that variable, to make that 1, you multiply by the multiplicative inverse. So it's 1 over 35 times 35. And you have to do that to both sides. 1 over 35 times a negative 490 equals 1 over 35 times 35b. These 35's cancel out. You're left with b. And a negative 490 divided by 35 is negative 14. Same as multiplying by 1 over 35. So now b is equal to negative 14. And what I did is I checked each of these equations with the solution. The solution is negative 14. So I replaced b up here with negative 14 here, and negative 14 here. And I zoomed in on this so you could easily see what's going on. So here's the negative 14, here's the negative 14. I'm not going to go through all this step by step, but you should. You should make sure that you understand each step, what's going on. And you just have to get it down to where one side is clearly equal to the other side. That satisfies the equation, that proves that that's the solution to the equation. So I got it down to 310/6 equals 310/6. I don't have to divide this. I don't have to make it simple or anything. Just have to get it down to what's written on the left side is the same as what's written on the right side. Up here, change this to thirds. I need to change everything to thirds to add the 75 plus a negative 70/3. So this is 225 thirds. And then I'm changing everything to sixths here, so I can write this in terms of sixths, and it comes out to be the same thing. 310/6 equals 310/6. Okay, this is problem G. This is the one that has two different denominators, but in the numerator it has a variable on both sides of the equation, and in one case you're subtracting a value from the variable, and in the other case you're adding a value to the variable. And also there's a negative sign here. This is a negative, this fraction right here. And I didn't list that over here. All right, so let's get rid of that fraction first. So how do you do that? I'm going to multiply through by, actually the first thing I'm going to do is separate out this 4 as 1/4, because 4m minus 3 divided by 4 is the same as 1/4 times this amount. So you can visualize this as moving the 4 over here as a factor and writing it as 1/4, because dividing by 4 is the same as multiplying by 1/4. Same thing over here. Dividing by 8 is the same as multiplying by 1/8. And that makes this a little bit easier to look at. Remember, this is a negative 1/8 right here. Now I'm going to get rid of the denominator by multiplying through by that denominator, 8. And this 4 will get canceled out also, because 4 is a factor of 8. So 8 times 1/4, and on this side, 8 times a negative 1/8. You only have to multiply that 8 by each term, and these terms are not separated out at all. They're all written together as a single term. So it's just 8 times this whole term here, and 8 times this whole term here. All right, so factor the 8 into 2 times 4 times 1/4. These 4's cancel out, and you guys know that 8 divided by 4 is 2 anyway. I just want you to see how the 4's cancel. And over here, 8 times a negative 1. This is a negative here, so this is a negative 1 times 8 over 8. And that separates out this negative 1, so it makes it easy to see, so you don't get confused. And this becomes a negative 1 right here. So notice up here, this is really a negative 1 times all of this. So it's a negative 1. It's the opposite of everything inside the parentheses together. So you're left with 2 times 4m plus a negative 3 equals negative 1 times 9 plus 4m. So 2 of these equals a negative, or the opposite of this. It's a way to look at that. Okay, now I'm going to distribute this 2 to both of these terms. So it's 2 times 4 is 8m, and 2 times a negative 3 is negative 6. So now it's easier to see distributing that 2, what's going on. And also a negative 1, so it's the opposite of 9 is negative 9. And I like to read negative 1 as the opposite. It just makes more sense to me. The opposite of 4m is a negative 4m. So this is negative 9 plus a negative 4m. And now I want to move things around, so I have just a variable is equal to a number. So the first thing I'm going to do is get rid of this negative 4m. And the way to do that is to add its additive inverse. What's the additive inverse of a negative 4m? Well, it's a positive 4m. And you have to do that to both sides. So add a positive 4m to this side. And as you get used to this, you're going to see that this negative 4m is going to disappear, and it's going to show up on the other side as a positive 4m. So basically it changes signs as it moves over to the other side. Probably not a good way to say it or do it. You're really operationally, mathematically, you're adding a positive 4m to both sides. Probably a better way to look at it. So 8 plus 4 is 12. You have 12 of these m's plus a negative 6, and you have just negative 9 on this side. This has disappeared. This has become 0. All right, I'm going to take a little bit of a shortcut here and just say that adding a positive 6, the additive inverse of a negative 6, is a positive 6. You're adding that to both sides. So this becomes 12m. Gotten rid of that because you're adding it with the positive 6. And on this side, a negative 9 plus a positive 6 is negative 3. And how do you get rid of that 12 right there? You turn that into a 1 by multiplying by the multiplicative inverse. So it's 1/12 times 12m is m, and 1/12 times negative 3 is a negative 3/12. This is not subtraction. I don't like the way I did this because it makes it look like subtraction. This is a negative 3/12. So it's 1/12 times negative 3, and that simplifies to negative 1/4. So m is equal to a negative 1/4. So I'm going to go up here and check that solution by substituting m with negative 1/4. So here's the negative 1/4. Here's the negative 1/4. And to go through, you just have to get it to where each side is equal, has the same term on each side. So negative 1 equals negative 1. So 4 times a negative 1/4 is negative 1. Now remember, you have to treat this as multiplying 4 of these things. You can't take the negative 1/4 and subtract the 3, because that's not what's going on. You have 4 of these things, and then you subtract the 3. You have 9 of these plus 4 of these things. So you have to figure out what 4 of these negative 1/4 are first, and then add that to the 9. So these 4's cancel. You're left with negative 1. Negative 1 plus negative 3 is negative 4. And over here, these 4's cancel out. You're left again with negative 1, but 9 plus a negative 1 is a positive 8. But these both equal negative 1. Negative 4 divided by 4, and the opposite of 8 divided by 8. They both equal negative 1. This is problem H. And the key to this problem is just making sure that the sign of what you're working with is makes sense. You're not making a mistake in changing the sign of either the variable or the number. And also you are faced with distributing a 5 here, and is that a negative 5 or a positive 5? And there's not even a number here. So how do you distribute that? What do you do? And so a way to keep that straight is to remember that subtracting a positive 5 is the same as adding a negative 5. So you can use the inverse operation and the additive inverse. So you can change this to adding a negative 5. So now you're clearly distributing this negative 5 times the p, and this negative 5 times that 4 right there. And it's the same thing here. Well, what goes here? Well, that is a positive 1. So right there is positive 1, and now you can use the inverse operation, which is addition, and the additive inverse, which is a negative 1. So subtracting a positive 1 is the same as adding a negative 1. So once again, subtracting this positive 1 is the same as adding a negative 1. So now you're clearly distributing that negative 1 to the 8. And what's going on here? This is subtracting p is the same as adding a negative p. So I'm going to do that one more time. Oh, actually, I did. So subtracting a p is the same as adding a negative p. It just helps keep the sign clear what it is, and it separates it from the operation. So people oftentimes confuse what the operation is with what's the sign of either the coefficient or the number that they're working with. You need to keep that straight. So this becomes p plus, and it's a negative 5p. So I'm going to underline what's being distributed. So it's a negative 5 times that p plus a negative 5 times that 4. So it's the opposite of 5 times these things. So it's the opposite of 5 p's plus the opposite of 5 4's. So it's a negative 5, and over here it's a negative 1 times 8. So it's the opposite of a positive 8, and it's the opposite of a negative p, the opposite of a negative p. So now you can rewrite these. So p plus a negative 5p, this becomes negative 20 right here. This is negative 8, and the opposite of a negative p is a positive p. It's hard. You have to carefully keep track of what the sign is. That's what I think is the hard part of this problem. So this is, if I have a negative 5p and this is a positive 1p, this is negative 4p. Negative 20, I have 1p here plus another p there, that's 2 p's, plus a negative 8. Now I want to get rid of the numbers on one side and get rid of the coefficients or the variables on the other side. And so what I'm going to do first is I'm going to get rid of this negative 4p. I want to work with positive p's. And so I'm going to get rid of the negative p's, add the additive inverse. The additive inverse of a negative 4p is a positive 4p. This becomes 0. You're going to be left with negative 20. And 2p plus a positive 4p becomes 6p. And you're going to be plus a negative 8. And so now I want to get rid of this negative 8 by adding the additive inverse, which is a positive 8. This becomes a negative 12. Negative 20 plus a positive 8 is negative 12. On this side, this negative 8 plus positive 8 disappears. That becomes 0. And I want to get rid of now this coefficient. You multiply by the multiplicative inverse. The multiplicative inverse of 6 is 1/6. A lot of people say, well, just divide by 6. I like using the multiplicative inverse, and I like using the additive inverse. That way you only have to think of two things: the operation of multiplication, the operation of addition, and using the multiplicative inverse and using the additive inverse. That's all you have to think about. You don't have to think about division, subtraction, anything else. And so I'm going to multiply through by the multiplicative inverse. So negative 12 times 1/6 is a negative 12/6. That's going to simplify, factor out 2 times 6. This is a whole negative term. So you can write this as a negative 12/6, a negative 12/6. The 2 times 6, those 6's cancel out, and that is equal to a single p, because 1/6 of 6 is 1. So if you have 6 things and you have 1/6 of those 6 things, you have one of those things. So this becomes 1p. And that p then is equal to negative 2, because you're left with negative 2 right here. So p equals negative 2. Check that by substituting negative 2 into this equation up here. So negative 2 right here, negative 2 plus 4. This is hard because you start to look at this. Oh, is this subtraction here? Negative 2 minus 5? Well, it's a minus 5 times this whole thing. It's not a minus 5 times this whole thing. It's 5 times this whole thing. So you have to work with this together first. Are you subtracting all of this, or actually it's the opposite of all of this? So you have to work with all of this first. This becomes hard. So I'm going to distribute. Oh, actually, because they're all numbers now, I can just do the calculations. This is 2. This is 8 plus it. See how you do this? You've learned that if you subtract this negative 2, you look at it as using the inverse operation, addition, and adding the additive inverse, positive 2. So 8 plus 2 is 10. So it's not any different than what we've been doing. And this is a negative 2 minus 10. Negative 2 minus 10. You don't have to go any farther if you can show that this side is also a negative 2 minus 10. This side is equal to 10 because 4 plus a negative 2 is 2. And this 5 times 2 is 10. So you're left with negative 2 minus 10 on this side equals negative 2 minus 10 on this side. That equals negative 12, by the way. And this equals negative 12. And the way that I do that just in my head is a negative 2 plus a negative 10 equals negative 12. The next three equations I thought were a bit easier to solve. And those equations are C, E, and J. And in equation C, to solve this equation, you can get rid of this 4 in the denominator by multiplying through by 4. So this 4 times force will cancel out this 4 in the denominator. But once you do that, you end up with 8 here. This becomes 4 times 2, and that 8 needs to be distributed. But that's not too bad. The next one, again, multiply through by the 7 to get rid of the 7ths. So 7 sevenths becomes 1. And you have to remember to multiply each term by 7. And then you collect like terms and move terms around, and you can get to the solution. And J, this is a little bit more difficult in that you're going to distribute this negative 8 to negative r, and this negative 8 to a positive 5. Now I will change this to adding a negative 5, And so this becomes a negative 8 times a negative 5, which is a positive 40. But notice if you distribute that as it is right here, this is a negative 8 times a positive 5, which is a negative 40. And then to subtract a negative 40, you usually look at that as adding a positive 40. So you make that change anyway. So I just tend to do it right in the beginning. So we'll take a look at that. Okay, for equation C, first thing I want to do is get rid of this 4 in the denominator, get rid of the fourths. So you can do that by multiplying by 4. Now you can look at this as 1/4 times 10 plus a negative v. And I also changed, this is subtracting a positive v, and so I used the inverse operation of addition and the additive inverse of negative v to make that change. If you look at this as 1/4 times this amount inside the parentheses, then you can see 4 times 1/4 is 1. Or you can leave it down here. It gets canceled out, and you're left with 10 plus a negative v. And that equals, remember you have to multiply that 2 times the 4 as well. So this becomes 8 times v plus 17. So you have to distribute that 8 to the v and that 8 to the 17. And you're left with 10 plus negative v equals 8v plus 136. And I want to get this 8v by itself. So I'm going to get rid of the 136 by adding the additive inverse of 136, which is a negative 136. You have to do that to both sides, and so you can almost think of that as this 136 moving over to the left side, but becoming negative because you're adding a negative 136 over here. So 10 plus a negative 136, and notice adding a negative 136 to 10, that becomes a negative 126 plus a negative v equals 8v. So you've gotten rid of this part. And now you want to get rid of this negative v by adding its additive inverse. The additive inverse of a negative v is a positive v. So I'm going to add a positive v to both sides. And so again, this negative v is going to move over here and become positive v because you're adding positive v to both sides. So this is adding the positive v. This becomes 0. And 8v plus a positive 1v, that's 9v. And to get rid of this coefficient, you multiply by the multiplicative inverse, which is 1/9. So 1/9 times 9 is 1. So you're left with v equals a negative 14. I switched these over the equal sign. So this v equals negative 14. Negative 126 divided by 9, or 1/9 of a negative 126, is negative 14. Now to check that in the equation, plug negative 14 back into the equation. So here's v is equal to negative 14, and this v is equal to negative 14. And notice what you do right off the bat. You subtract a negative 14, so you're going to add a positive 14. So 10 plus a positive 14 is 24. So I make that change right away in the equation up here. So a positive adding a negative v. So adding positive 14, get a little bit. That's because, so if I change this to adding a negative v, the opposite of v, which is negative 14, is a positive 14. Sorry about that. And so this is 10 plus a positive 14, that's 24, divided by 4 is 6, and 2 times 3, this becomes 3, is also equal to 6. This is equation E, and to get rid of the sevenths, I'm going to multiply by 7. 7 times 1/7 is going to give me 1 of these n's. But you have to also remember to multiply each term by 7 if you're going to do that. And I'm also going to change this subtracting a positive 12. So remember, this is positive 12. I'm going to change subtracting a positive 12 to adding a negative 12. So I'm going to use the inverse operation of addition and the additive inverse of negative 12. So I'm going to add negative 12. So I'm going to go through and multiply each of these terms by 7. The reason I'm doing this, by the way, and I'll go back through this again, is I want to change everything to addition. It's just easier for me to think about addition than it is subtraction. And oftentimes you end up making that change anyway. And so 7 times n sevenths. This is 1/7 times n. 1/7 of n. If you have 7 times that, you're going to end up with 1n. This is 7 times -12, 7 times 5n, and 7 times 5. Now another way to do this is to realize that a common factor of 5n and 5 is 5. So if you divide by 5, you end up with 1n. You divide this 5 by 5, you end up with 1. But you have 5 of those things. So 5 times n plus 1. And then you can multiply this by 7. 5 times 7 is 35. And then distribute that 35 to n. So you have 35 of these n's, and you have 35 1's. That's one route they can use to simplify this to 35. Actually, you multiply through by 7. A second route is just to continue down this way, and you're going to end up with 7 times each term. This 7 times 5 is 35n, plus this 7 times 5 is 35. So you end up with the same thing. 35n plus 35, 35n plus 35. So whichever route you take, this route or this route, you end up in the same place. So it's really up to you what you think is easier to do. So now I want to get rid of this n on this side. So I'm going to add a negative n to this positive n to make this equal to 0. So I'm going to add a negative n to this side. Now I could add a negative 35n to this side and add a negative 35n to this side, but that's going to make these n's negative. I'd rather have them be positive. It's just easier to work with positive variables, variables. All right, so I'm going to add a negative n to this side, get rid of this positive n, and do the same thing on this side. So I add a negative n, that makes this 34n. And so you end up with a negative 84 equals 34n plus 35. And so now I want to move this 35 over to this side by adding a negative 35. So it's going to be a negative 84 plus negative 35. End up with a negative 119 equals a positive 34n. All right, so now if I have 34 n's, I want to know what 1n equals. And so I'm going to look at 1/34 of those 34 n's, which means I also have to look at 1/34 of this side. Both of these are equal to each other. This 34n is equal to negative 119. So if I look at 1/34 of this side, I also have to look at 1/34 of this side. So 1/34 of both of those sides. This is now 1n, but this is that 1/34 of a negative 119. So this turns into a pretty tough fraction to look at, negative 119/34. Now, the authors usually set these problems up in a way that they can be simplified relatively easily. This one's not so easy. But if you look at 34 and you ask the question, all right, I have 119 of these things. How many times can I take 34, a group of 34, out of 119? Well, you know that 3 times 33 is 99. That gets you pretty close to 119. 3 times 34 is going to be 3 more than 99, or 102. And what do you have left over? You're going to have 17 34ths left over. So you're going to have 3 and 17 34ths. So 3 times 34 is 102. Then another 17 gets you up to this 119. So, but they're all negatives. So this is a negative 3 and 17 34ths. The reason I want to do that is because 17 34ths is equal to 1/2. So this gets me to a negative 3 and 1/2. Now, of course, you could just plug this into a calculator, but it's much easier, and you get 3 and 5/10, by the way, but it's much easier, it's much better to think through it. How does this become a negative 3 and 5/10? So it's 3 whole groups of 34 plus 17 left over, and then realize that 2 times 17 equals 34, so that equals 1/2. Now, this is a rather difficult fraction to plug back in and test the equation to test whether or not this is a solution to this equation. So it's negative 3.5. You replace this n with negative 3.5 and this n with negative 3.5. So you make that replacement, and I'm going to zoom in on this. So this was n here, so it's negative 3.5, and this was n here, negative 3.5. All right, so now, again, the authors are going to set these problems up so you can work through them relatively easily. Look for little clues to do that. Well, I have sevenths as the denominator, and if I change this to an improper fraction, I'm going to end up with 7 as the numerator, because 2 times 3 is 6, plus 1 more is 7, so that's a negative 7/2. So a negative 2 times 3 is a negative 6, plus another negative 1/2. This is a negative 1/2, so remember that. So negative 6/2 plus another negative 1/2 is a negative 7/2. So now those sevenths cancel out. If I have 7 1/2, and I look at 1/7 of that, that's going to give me just 1 1/2, but it's negative. This is a negative 1/2 right here after you cancel the sevens or take 1/7 of that. So this is a negative 1/2 minus 12. Well, to combine these, you look at this as adding a negative 12. So here you're changing this to adding in the additive inverse. So add a negative 12. That gives you a negative 12.5. So you have to think about this. Negative 1/2. If you're going to subtract 12 or add a negative 12, that's going to give you a negative 12.5. So you've worked on this side. Again, make the same change to an improper fraction. So this is a negative 7/2, just like over here. This becomes a negative 7/2 over here. But now you're going to multiply. You're going to have 5 of these negative 7/2. Well, 5 of those negative 7/2 gives you a negative 35/2. This is pretty hard to talk through. Now, I have 5 whole units, and I have a fraction. I'm going to an improper fraction. I want to have whole things, but in this case, they're negative whole things. But I still want to have whole things that I can add to this 5. And so if I change this to a mixed number, this is a negative 17.5. So now I can add 5 whole things to that. It's just easier. It's an easier calculation for me to do. Tough to talk through, but it's an easier calculation to do. So negative 17 plus a positive 5 is negative 12. And you have to remember that this right here is a negative 1/2. So this is a negative 17 plus a negative 1/2. So negative 17 plus 5 is negative 12.5. And that is equal to the left side, which is also a negative 12.5. Tough to talk through. I would suggest that you get on a blank sheet of paper, you write this down, and you go through each of these steps on your own and see if you end up with this negative 12.5. You might end up with something different. As long as they're equal on both sides, that's okay. And talk through it with a partner or on your own, but just work through it. Don't simply use a calculator and make those calculations. This is equation J, and the one part to pay attention to in this problem is distributing this negative 8. So this is negative 8 times negative r minus a negative 8 times a positive 5. This is a positive 5 right here. And to make this a little bit easier for me to deal with, it might not be for you, but for me it is, I'm going to change this to addition. So this is going to be, instead of subtracting a positive 5, I'm going to change this to adding a negative 5. And you can do that. This is the inverse operation, and this is the additive inverse. So subtracting 5 positives or subtracting a positive 5 is the same thing as adding 5 negatives or adding a negative 5. And so now when I look at this distribution of this negative 8, it becomes a negative 8 times negative 5. And if you think about it, that is a negative 8 is the opposite of 8. And so if I look at it as the opposite of 8, then it's the opposite of 8 times negative 5. And 8 negative 5s gives me an answer of negative 40. And the opposite of that negative 40 is positive 40. Likewise, this is 8 times a negative r. So if I have 8 negative r's, that gives me a negative 8r. Hard to talk about once again, but the opposite of that negative 8r is a positive 8r. Now, most students are taught to memorize the rule, a negative times a negative is positive, but it's important to try to understand why that's happening. So if you look at the first negative as the opposite of a negative is positive. So a negative times a negative gives you a positive value. A negative 8 times a negative 5 is a positive 40 because it's the opposite of 8 times negative 5, which is negative 40. The opposite of that is positive 40. So just think about that for a while. It will begin to make sense to you. I've found for a long time now, I think it's easier to look at the first factor, if it's a negative factor, to look at it as the opposite of that factor, the opposite of 8 times these things. And that then you change the answer, whatever it is, to the opposite sign. So one more time, the opposite of 8 times negative r, 8 times negative r is a negative 8r. The opposite of that is a positive 8r. And so now it's just a matter of eliminating terms and getting the numbers on one side and the variables on the other side. Now I can get rid of this 2r by adding a negative 2r. And I could get rid of this 8r first by adding a negative 8r to the positive 2r, but that would give me a negative 6r on this side, and I would rather work with positives. So if I get rid of this 2r first, that gives me a positive 6r on this side, because this 8r plus a negative 2r is 6r, and so now I'm left with 49 and 40 plus this 6r. So now I need to get rid of the 40 because that's on the same side as the variable, so I'm going to add a negative 40. So 40 plus negative 40, that becomes 0. 49 plus negative 40 equals 9. And so I need to get rid of this coefficient. If I have 6 r's, then 1/6 of that is 1r. So I'm going to multiply by the multiplicative inverse. It's the same as dividing. 1/6 times 6 is the same as 6 divided by 6. And that might be easier for some of you to look at it that way. Doesn't matter. 1/6 times 9 is 9/6. And I have to, if I'm going to look at 1/6 of this amount, I have to look at 1/6 of this amount, because this amount, 6r, is equal to 9. So 1/6 of 6r is r, which means 1/6 of 9 is 9/6. So 1/6 of 9 is 9/6, and you can simplify 9/6 to 3/2. So factor the 9 into 3 times 3, factor the 6 into 2 times 3. These 3's cancel out. They are equal to 1. So you're left with 3/2. So r equals 3/2. And then you can just flip it over the equal sign. You can mathematically go through why that is, but it's not too hard to just recognize r equals 3/2, r equals 3/2. And remember that 3/2 is the same as 1 and 1/2. So here's the 2/2 plus 1/2, that's 3/2. But these 2/2, remember, are equal to 1. So r is equal to 1.5, or r is equal to 3/2. Now to check the solution, it's much easier to work with 3/2, because one of the first things you're going to do if you work with 1 and 1/2 is change it to an improper fraction. So just begin with this improper fraction. So replace r with 3/2, replace r, this is a negative r, so it's the opposite of 3/2. So the opposite of 3/2 is right here. And as you work through, I'm going to zoom in on this. As you work through this 2 times 3/2. So I have 2 of these 3/2. And I have to work with that part first, because this says I have 2 of these things. You cannot add 49 plus 3/2 first, because you have 2 of these things. You have to resolve that part first and then add that to the 49. So 2 divided by 2 is 1. You're left with 3. 3 plus 49 is 52. So this becomes, the left side is equal to 52. The right side, a little bit more difficult. This negative 3/2 plus a negative 5. So this is, instead of subtracting a positive 5, you're going to add a negative 5. A little bit easier for me to look at this as a negative 3/2 plus a negative 5 equals a negative 5 3/2. I actually didn't write that change in here. I probably should have. So this is now a negative 8 times this amount. So a negative 8 is the opposite of 8 times this amount. Now 5 3/2 is the same as 6 1/2, but they're negatives. So this is a negative 6 1/2, and it's times a negative 8. Now, a little bit tricky here. There are a couple ways to do this. One is you can change this to an improper fraction. You get a negative 13/2. 8 times 13 is actually 104. Half of 104 is 52. Or it's easier for me to do it in my head if I look at this as 6 plus 1/2. So this is a negative 6 plus a negative 1/2. You have to remember that this is a negative 1/2 as well. So using the distributive property, it's a negative 8 times negative 6, which I can do in my head now. So 8 times 6 is 48, but this is the opposite of 8 times negative 6. 8 times negative 6 is a negative 48. The opposite of that is a positive 48. And you're going to add that to a negative 8 times a negative 1/2, because this is a negative 6 plus a negative 1/2. So negative 8 times a negative 1/2. And here I'm just showing you that the opposite of a negative 1 is a positive 1. So negative 1 times a negative 1 is a positive 1. So then you can look at this as 8 times 1/2. And 8/2 is equal to 4. So 2 times 4 is 8. Divided by this 2 or multiplied by 1/2. These 2's cancel out. They become 1. You're left with 4. And you know that 8 divided by 2 is 4. That's not a surprise. And then 48 plus 4 is equal to the 52. So I'm doing this a little bit differently here, and I want students to see different ways to look at this. So you could immediately go to an improper fraction. You could change this to an improper fraction. This is a negative 13/2. But it's interesting to look at it also as this is a negative 6 plus a negative 1/2, and then use the distributive property. Little things that might make it easier for you to do these calculations in your head rather than always immediately turning to a calculator. The 4 equations that are in between, being a bit on the easier side and a little bit more on the more difficult side, those 4 equations that are in between are equation B, D, F, and I. So beginning with equation B, it looks fairly simple. There's one variable here, t, and you have to distribute this negative 1/2. You have to think about whether or not you want to change this to addition. I always do. And there's a decimal here. So there's a few things going on. But if you look at this as distributing this negative 1/2, so it's a negative 1/2 times t. And I try to look at this as the opposite of 1/2 t. And the opposite of 1/2 t is a negative 1/2 t. And then the opposite of 1/2 of 3, which is 3/2, is a negative 3/2. So if you read that negative sign right there as the opposite of, do the multiplication and just take the opposite of that, you end up with a negative. So this is another example of why a negative times a positive gives you a negative answer. It's the opposite of those 2 positive values being multiplied together. And then I'm going to change the subtraction of a positive 10 to adding negative 10. So adding negative 10, and it equals a negative 6 5/10. All right, so now we have a negative 1/2 t plus, and this is interesting, this is a negative 10 plus a negative 3/2. So this is similar to the previous problem in that you have a negative number, or negative integer actually, and you're adding that to a negative fraction. So that's more negative. So this is a negative 11 1/2. So a negative 10 3/2 is the same as a negative 11 1/2. And that equals a negative 6 1/2. I'm going to change this decimal value to a fraction. Now if I add a positive 11 1/2 to both sides, this becomes 0. And I'm adding a positive 11 1/2 plus a negative 6 1/2. And this becomes interesting to look at as well. So now you have a positive 11 If you separate each of these mixed numbers out into adding the fraction plus the integer, then you get a positive 11 plus a positive 1/2 plus a negative 6 plus a negative 1/2. Well, that positive 1/2 plus a negative 1/2 equals 0. And so you're left with 11 plus negative 6. 11 plus negative 6 equals 5. Several ways to think about it. I learned to think about this as 11 1/2 plus a negative 6. It gives you 5 1/2 plus another negative 1/2 will bring you to 5 as the answer. A couple of different ways to think about that. A negative 1/2 t equals 5. So to get rid of this coefficient, negative 1/2, we're going to multiply by the multiplicative inverse, which is negative 2. So negative 2 times a negative 1/2 is equal to t, is equal to 1, and you have 1t. So another example of why a negative times a negative is a positive. So negative 2 times a negative 1/2, those are multiplicative inverses. They multiply together to equal 1. So you're left with 1t equals negative 10. So t does equal negative 10. And to check that solution in the equation, you replace t up here with negative 10. I'm going to zoom in on this a little bit. So if this was t, it's now negative 10. So negative 10 plus 3, negative 7. That's a negative 1/2. So 1/2 of negative 7 is a negative 3.5, and the opposite of that is a positive 3.5. I'm going to subtract 10. I'm going to look at this as adding negative 10. So 3.5 plus a negative 10 it's going to be negative 7, and then another positive 1/2 is going to bring this to a negative 6 1/2. A little bit hard to think about. You might put this on a number line, thinking about it that way. And on this side, this just remains a negative 6 5/10, or a negative 6 1/2. So these two sides are equal to each other. Okay, the next equation is equation D. A couple things to notice. There's a distribution here, 2 times whatever's inside these parentheses, and 2 times whatever is inside these parentheses. And in both cases, you're going to subtract a positive 13. I'm going to change that to adding a negative 13. Subtract a positive 13. I'm going to change that to adding a negative 13. It's just easier for me to work with addition than it is subtraction. I can move the terms around, and it helps me keep track of the signs of the terms so I don't mix those signs up. Now, I wish I had noticed in the beginning that if I added a positive 13 here, this becomes 0, and add that same positive 13 here, this becomes 0, then I would have been left with 8k plus 6 equals 2 times 18 plus a negative k. Work through that, you're going to end up with 10k equals 30 fairly easily. I didn't notice that at first, so what I did is first of all, I use the distributive property, so this becomes 36 plus a negative 2k plus a negative 13. And then to get rid of this negative 7, I added a positive 7, so here's the positive 7 here. To get rid of this negative 2k, I added a positive 2k, so here's the positive 2k here. So this becomes 10k, that's not too bad. A little bit harder to add these together, but you might notice that 7 plus 36 is 43, and 43 plus a negative 13 gets you back to a positive 30. So 43 plus a negative 10 is 33, plus a negative 3 gets you to 30. So you end up with 10k equals 30, the same as the other route if I remove this negative 13 first. And then 1/10 of k is k, and 1/10 of 30 is 3. So k equals 3. So replace that 3 up here for this k, and that 3 up here for this k. And I'm going to zoom in on this. So now you have, this was k, so now you have 4 k's. So you have 4 3's. You have to work with this multiplication first before you add the 3. You cannot add this 3 plus this 3 because they don't go together. Another way to look at groups of things is through multiplication. So 4 groups of 3 things. 4 times 3 is 12. And now you add the 3. That's 15. So now you have 2 times 15 minus this 13 still. And over here, using these parentheses, tells you that this goes together as a group. So now you subtract the 3 from this 18, so you get 2 times 15 minus 13. So the same thing on each side. So both sides are equal to each other. So you've shown that, in fact, 3 is a solution to this equation. 3k does, in fact, equal 3. The next equation, equation F, there's a little bit more to look at in this equation. This is distribution of this 3, subtracting a 1, so I'm going to change that to adding a negative 1 in a moment. The distribution of this 2, so 2 times 3, c, and 2 times 1, and this is a negative 1 here. So you're not distributing the negative sign, you're distributing a negative 1. So this is a negative 1 times 3c, or the opposite of 3c, and the opposite of a positive 1. So if I change this to addition, adding a negative 1, and 2 times 3c plus 1, I haven't made any change there, but this is the opposite of 3c, which is a negative 3c, and the opposite of a positive 1, which is a negative 1. So you're distributing, once again, this negative 1. Now I've made everything addition because I want to move things around. But the first thing I need to do is distribute this 2. So 2 times 3c is 6c, plus 2 times 1 is 2. So now everything is addition. So now I can move things around more easily. So this 3c plus 6c is 9c. This negative 3 plus positive 2 is negative 1, equals a negative 3c plus a negative 1. Now, I could have added a positive 1 here and a positive 1 here, and this would become 9c equals a negative 3c. And then you have a factor times a number is equal to a factor times a different number. The only way that could work, the only way that could be true, is if c equals 0. So we'll see if that's true when we work through this. So 9c plus a positive 3c. So remove this negative 3c here by adding a positive 3c. Remove this negative 1 here by adding a positive 1. And a negative 1 plus a positive 1 equals 0. So you end up with 12c equals 0. And what does c then have to be? C has to equal 0. And to prove that c is actually equal to 0, so you're going to replace this c up here with 0, this c with 0, and this c with 0 up here. I'm going to zoom in on that just for a moment. So this is 0 minus 1, negative 1. 3 times 0 is 0, so oftentimes you multiply anything by 0 is 0, so it becomes a little bit easier to work with. This is 1. This is a positive 1, but it's the opposite of a positive 1. Remember, it's negative 1 times this. So this is actually a negative 1. So negative 3 times 2 equals negative 1. I'm sorry, negative 3 plus 2. So negative 3 plus 2 is negative 1. So you end up with negative 1 equals negative 1. Now you may have noticed that this is the same here. 3 times 0 plus 1 is the same as 3 times 0 plus 1. So you can take advantage of that. 2 of these things and a negative 1 of these things. So now you can add those together. So what I've done is this is 2 of these things right here and 1 of these things. And if I add 1 of these, a positive 1 of this to both sides, I'm going to end up with 3 of this 3 times 0 plus 1. Hopefully this makes sense to you. Think of it as 2a equals a negative a. If I add a to both sides, I'm going to end up with 3 a's. So 3 of these things. So negative 3 plus, this becomes positive 1, because 3 times 0 is 0. So you end up with 1. So 3 times positive 1. So negative 3 plus a positive 3 equals 0. And in fact, it does. A negative 3 plus a positive 3 equals 0. So you end up with 0 equals 0. A little bit weird to think about and weird to look at. You might think through that and see if that makes sense to you. The last equation is equation I. And this one's not too bad. There's 2 groups of 2q plus 1 and 5/10. So you have to distribute that 2. That gives you 4q's plus 2 times 1 1/2 is 3. And over here, I'm going to change this to addition. I'm going to add a negative q. So this becomes 4q. 2 times 2 is 4q's. You have two groups of these things. That means you're going to have 4q's total plus 2 1.5s. So 2 times 1.5 is 3. So 4q plus 3 equals 18 plus a negative q. So now I'm going to add a positive q to this side to get rid of the negative q, and I'm going to add a negative 3 to both sides to get rid of this positive 3. So add a positive q here, that gets rid of this negative q, and add a positive q here, this becomes 5q. Add negative 3, so 18 plus negative 3 equals 15 on this side, and 5q on this side. Well, 1/5 of 5q is equal to 1/5 of 15. 1/5 of 15 is equal to 3. So q equals 3. So you go back up here and replace this q with 3. So 2 times 3 is 6. And replace this q with 3. So subtracting a positive 3. Zoom in on that a little bit. So 2 times 3 is the 6. And then add that to 1.5. So 2 times 7.5 does equal 15. And on this side, 18, I could say plus a negative 3, or 18 minus a positive 3 is equal to 15. So you get 15 on this side. So you end up with 15 equals 15. So 3 is in fact a solution to this equation.